In this video, we are going to learn about factors affecting reaction rate. Each reaction has own characteristic rate, and that's how the reaction rate is determined by the chemical nature of reactant. This is the 5 factors that influence the reaction rate. First, concentration. Second, pressure. Third, particle size. The fourth one, temperature. And the last, catalyze. Now we look at first factor, which is concentration. The more particle of reactant, the more concentration of reactant, because when more particles are present, more effective collision will occur. Thus, the reaction rate will increase. Secondly, is pressure. When pressure is low, the concentration becomes low. On the other hand, when pressure is high, the concentration also becomes high. When volume is decreased, pressure will increase and molecules are close together. More effective collision will occur, thus the rate of reaction will increase. The third one is particle size. When size particle is decreased, the surface area exposed also increase and the reaction become increased. More effective collision will occur, thus the reaction rate will increase. And the next factor is temperature. As temperature higher, average kinetic energy of molecule also higher. More molecule with enough energy equal to or greater than activation energy will collide. The frequency of effective collision will increase, thus the rate of reaction will increase. The effect of temperature can be described by using Maxwell-Boltzmann distribution curve. Maxwell-Boltzmann distribution shows the kinetic energy distribution for a reaction mixture at two different temperatures. From the diagram, at higher temperature T2, molecules that have kinetic energy equal or greater than activation energy is small compared to the T1. Only collision with energy greater than EA are able to react. This is because when temperature increases, average kinetic energy of molecule increase, number of molecules with energy equal or greater than EA increase, effective collision increase, and rate of reaction will also increase. And the last factor that influences rate of reaction is catalyst. The function of catalyst is speed up the reactions, and catalyst did not take a part in the reaction. Catalysts provide an alternative pathway which has a lower activation energy compared to the one without catalyst. Now we are going to learn about calculation involved by using the Arrhenius equation. The formula of Arrhenius equation is K equal to A exponent negative EA over RT. What is variable mean? K rate constant, A frequency factor, exponent based on natural logarithm, EA activation energy, R universal gas constant, T absolute temperature in Kelvin. From Arrhenius equation, magnitude of both activation energy and temperature will affect the rate constant, which eventually affect the rate of reaction. As a conclusion, when temperature is high, value of K is increases, as well as its rate. Same goes when we have smaller activation energy, both rate constant and rate of reaction increases. From Arrhenius equation, we can get second equation by applying ln on both sides from the following equation. But when we were given rate constant value at two different temperatures, the formula will be like this. Assignment of K1 and K2 will depend on data given in the from graphical method, how we determine an activation energy. Determination of activation energy using graphical method can be done using the following equation. The equation ln K equal to negative EA over R times 1 over T plus ln A can be compared with linear equation of Y equal to mx plus C, whereas ln K is Y, 1 over T is X, M is the gradient negative EA over R. Negative sign indicate negative slope as shown on the graph. Lastly, ln A is y-intercept C. From the slope, EA can be determined from the graph. And please remember, value of the gas constant used must be 8.314 joule per mole per Kelvin. We use this value due to the unit of energy in joule or kilojoule. That's all for the chapter 1. Thank you for watching until the end of this video.